This is Devam Trivedi and I'm currently a master's student in robotics at WPI University. This is a presentation on a paper titled Design of Hesitation Gestures for Nonverbal Human-Robot Negotiation of Conflicts. Speaking about conflicts, we can think about human-human interaction as well as human-robot interaction. Let's say we have a table on which we have a single resource which is to be shared by both a human and a robot. In such a situation, when a robot and a human reaches for the same resource, it is difficult and leads to conflict as to who will get possession of the resource. Thinking it from a human-human point of view, if two humans are experiencing conflicts regarding priority to accessing of the shared resources, there trespasses a non-verbal communication within each other and which leads to negotiation of a solution. Now, the humans express uncertainties through a variety of non-verbal cues such as frowning, shrugging, putting palms up, exhibiting self-touch gestures, also hesitation to speak or act. The solution to this would be that one of the humans yields the objects to another or claims the object before the other one obtains it. Hesitations in humans can be termed in two types, R-type as well as the P-type. The R-type hesitation involves the hesitating agent where the human immediately yields to the other agent upon encountering a resource conflict. This type of hesitation behavior when applied on a robot is more recognizable by a human when it is generated artificially using the acceleration based hesitation profile. Whereas the P-type conflict involves involves engaging in a non-verbal dialogue, that is a back and forth dance of hands midair by the two agents negotiating the conflict until a resolution is reached. Along with hesitation, persistency also plays an important role in negotiation, which will also be covered deeply in this paper. Persistence is seen as a proactive behavior that is a necessary component of ongoing negotiation between the two parties, which can either be human-human or a human-robot. This paper presents two studies, out of which the first study involves the observing and labeling of hesitations in human-human dyads. Over here, the dataset consists of varying degrees of perceived persistency and hesitancy that people perceive from the recorded instances of hesitations. In this, we have 16 volunteers and 9 cameras are used. Of these, there are pairs of participants in which each participant wore 7 reflective markers, as you can see, one on the shoulder joint, one on the elbow joint, one on the wrist joint, and other 4 on the fingers and the palm joints, since they have and the wrist, since they have a higher amount of movement throughout the actions. In front of them were kept a deck of randomly ordered cards, which was split into 2 piles. Now, the setup was such that the two participants faced each other on a table and the deck of cards was in front of them, and near to each of the participants were 2 aces of the same color, either red or black. Now, the task was to order the 2 full sets of cards hierarchically in such a manner that they are alternating color as fast as they can. The accessing of the 2 piles of cards in an alternating order was to grab and return only one at a time. As a result, more than 300 trajectories of hesitation and gesture samples was generated. The 300 participants that surveyed and recorded a persistency and hesitancy scale of 1 to 7. That is, each participant viewed the videos, the 302 trajectories, and each participant rated the trajectories that were followed by the humans based on a persistency and hesitancy scale of 1 to 7, in which 1 relates to not hesitant at all and 7 relates to extremely hesitant. That is, if a particular participant gave a particular scenario a rating of 6, that means that that particular person found that the participant who was in the video was very much hesitant towards picking up the cards. The mean of persistency score was around 4, whereas the mean of hesitancy score was around 4 and 4.5. This data that was collected was further analyzed for human motion. Now we see over here the human negotiative hesitation trajectories. That is, the trajectories that a wrist follows when a human encounters certain type of hesitation. Over here, we can see the two graphs where the hesitation samples are traced in a state space of del t versus del dot t, where del t corresponds to the distance traveled, whereas the del dot t corresponds to the velocity of the hand. Overlaying all the hesitation samples demonstrates that there are certain hesitation loops which are being created in the state space, which is common to all the samples. Over here, we can also see something known as kickback distance, which while the negotiative hesitation took place, what is the amount of distance that a particular participant took back, that is moved when hesitation is being encountered. We can see that most of the hesitations are in between 5 to 20 millimeters. Upon reviewing all the hesitation loops, we can see that there are four hesitation loops which are being conducted over here. Let's study the first of it. We can see over here that initially when the participant starts, they are further away from the target than the participant, and also they are slower than the participant. As they move towards the target, their speed increases and approaches that of the participant, and then for a while it increases more than the opponent's speed. The main participant over here then faces hesitation, as can be seen over here, and retracts the hand, as a result of which the main participant goes further away from the target, as well as the velocity of the main participant is lesser than compared to velocity of the opponent participant. In case 2, we can see that the participant is initially closer to the main participant is initially closer to the target than the opponent participant, and when it tries to reach the target, that is the deck of cards over here, they momentarily are slower in velocity than the main participant, than the opponent participant, since they might be faster in reaching the target, and as a result it leads to hesitation, and the main participant retracts their hand and goes away from the target, and therefore also the opponent participant. We can see both of the cases repeat in case 3 and 4, in which case the main participant is slower than the main opponent participant in the initial phase, as well as faster than the main opponent participant in the initial case. Studying these negotiative trajectories and the spline loops that we have just seen, we can design a negotiative hesitation generator which will generate these splines in a robot. We have used over here a linear dynamical system that generates reference trajectories of artificial hesitations. Over here, the paper has proposed using a simple linear equation in which the rate of change is described as a matrix multiplied by an unambiguous states of robots, such as joint angles, and in addition to a vector in the vector space in which the experiment is being conducted. This method reduces jerk and results in a smoother motion compared to the one that is produced directly using quintic splines. The linear dynamical system, or the LDS architecture is composed of two main elements. First is the trigger state, that is the state at which the controller should trigger a hesitation behavior. The other is the kickback distance, that is the distance to retract as part of the hesitation behavior. This is also seen in humans, as in the trigger state is when a human encounters a hesitation and starts to retract their hand, or starts to engage in a non-verbal cues of negotiative hesitation. The kickback distance refers to the distance that is being retracted by the hands of a human when hesitation is being conducted. Overall, the process that the negotiative hesitation generator follows is that when a trigger state is detected, the equilibrium point is moved by a kickback distance, and this produces reference trajectories using quintic splines. As we can see on the bottom right over here, the simulation output, we have two hesitation behaviors, both which at a difference of 0.5 seconds, and as a result, when they come closer to each other, the main participant retracts its motion and reduces the velocity also. This results in a closed loop hesitation spline, as can be seen in the bottom right fourth graph of the output. Second study of this paper deals with validating the negotiative hesitation generator that we have just designed. The aim of this study is to demonstrate the robot motions that results from the energy and can communicate the hesitation to third-party observers. This study also aims to identify the values of KD and reattempts of RA that can be used for effective implementation of the negotiative hesitation generator. Over here, we can clearly see the setup as a robotic hand which controls two liquid pumps. In between a robot and the human, there is a dispenser which is controlled by a black button on the top. The human's task over here is to separate two heaps of lentils sorry, and put them in the dispenser by pressing the button. Now it may happen that the human and the robot alternatively goes for the dispenser, but once in a while it might happen, as we can see in the bottommost representation of the picture over here, that the robot and the person reach for the dispenser at the same time. This video was taken and it was shown to us 50 people surveyed the videos of the setting with different values of KD and RA that took place with the robot. The KD values are shown over here as 0 mm, 10 mm, 19 and 40 mm. Of this, we have the reattempts. RA means the number of reattempts that has been taken place by the robots, as in sorry. When hesitation is encountered, a robot retracts a KD distance and then reattempts to fetch the dispenser and press it using a Quintex spline. This number of reattempts is obtained as a number of attempts, which is 0, 1, 2, 3 or 4. This is also surveyed along with a condition of a smooth stopping, which was taken as a base reference. It was analyzed that hypothesis that was presented over here, that is, the robot hesitation responses generated by the energy are perceived to be more hesitant and persistent than a smooth stopping behavior, fares better, and this hypothesis is completely valid over here as seen from the surveying of 50 different participants. Over here we can see 4 equations which is how the analysis takes place. That is, when the kickback distance is 0 and the reattempts number are also 0, it is taken as mu naught, which is a base condition, also similar to the smooth stopping condition where it is a difference by just a small variable, that is tau. Considering these base conditions as mu naught, we have kickback distance equals to alpha, where the number of reattempts is 0. We can see them as mu naught plus KD when we have alpha, and similarly when the equations are studied and analyzed when we have kickback distance as alpha for varying values of alpha, as we can see in the table up, and also the varying values of reattempt, which can also be seen as beta, directed by beta, as seen in the values as mentioned in the table above. The results of this study were mainly focused upon reviewing the number of attempts and kickback distance with respect to persistency and hesitancy. The perceived hesitancy scores collected for the different levels of KD and RA suggested that the energy generated motions are there are significant differences in hesitancy among the human inspired values of KD. This tells us that this suggests that in the human-inspired values of kickback distance, there is a lot of differences in various values that have been taken in the study as being observed by the various observers. The robot motion generated with KD equals to 0 is perceived to convey a significantly higher level of hesitancy than those with higher number of KD, such as 10 or 19 mm. Although in this situation, the robot does not perform any reattempts, and still it conveys a higher level of hesitancy, which is quite counterintuitive. The persistency levels are also perceived with different levels of kickback distances and reattempt values. The energy generated motions are perceived to be significantly more persistent than the motion which is being implemented by the smooth stop condition. This study, however, has couple of limitations, such as the hypothesis could not be fully tested as there was lack of data available. Also, the second study that we saw just now is a video-based study only, and therefore cannot generalize the results of this study in real-life human-robot interaction. Today, the industrial robots are not typically equipped with motion sensors that is being used in this study, such as the 7 motion sensors that were being used to capture the motions of the entire hand in a detailed manner. Many robot manipulators do not use the quintic splines and the LDS as we have considered in this paper, which are very much human-like, but instead use trapezoidal trajectory profiles to generate motion. It may be unrealistic to expect the proposed seeing all these points in keeping all these points in mind. It may be unrealistic to expect the proposed energy to be implemented in industrial manufacturing environment as it is today. However, with a certain changes and considering more real life situations, it can definitely be improved and put up into in the real life. The the negotiative human trajectory is a trajectory generated that is presented in which we can investigate the role robot negotiative hesitations can play in an interactive human-robot resolution of resource conflicts. Human hesitation trajectories that was collected and labeled in study 1 helps in identifying the characteristic features that was necessary to create human recognizable hesitations. The results from this study informed about the design of a negotiative human hesitation generator and the values of its parameters that needed to be taken into consideration, such as the kickback distance and the number of reattempts. Study 2 results demonstrate that the energy generated motions are indeed distinguished from smooth stopping behaviors of robot, which is commonly being used nowadays. These results provide empirical support for the use of energies for in-person HRI, where human behavioral responses to the artificial hesitations can be observed. Counterintuitively, as discussed before, KD values as 0 and number of reattempts as 0 receive the highest hesitancy score, even though a KD equal to 0 implies no hesitation. Oppositely, the KD equal to 0 and RA equal to 0 value, although it did receive the highest hesitancy score, it received the lowest persistency score, since number of reattempts was 0 and as a whole cannot be considered as an effective way for a hesitation generator for a robot to perceive hesitation over here. Contrary to one of the hypotheses made earlier in the paper, the motions that are produced by a negotiative hesitation generator are perceived to be less dominant than that of the smooth stopping motions. This work contributes to a better understanding of negotiative hesitations naturally found in human-human interaction and provides a validated trajectory generator with which one can use to explore human and robot non-verbal negotiation of resource conflicts. Thank you.